Okay, so just the big idea here behind calculus, which is the tangent problem. So we're going to be looking at tangent line to a curve as instantaneous velocity. Before we start though, let's just define what we mean by a tangent. So the word tangent comes from the Latin tangens, which means touching, or just like barely touching. I think a lot of people first saw the term tangent from circle geometry, where you had to draw a tangent line to the curve. And we found that we could only draw one of them. In fact, with circle geometry, you may remember that if you drew a line from this point of tangency to the center, do you remember this, that you always got a right angle? I don't know when you did it. You used to do it in grade 9 and 10. Hey. Some of you are saying you did, some didn't. It's not that big a deal. So anyways, tangent, it just touches it in one point. So if we're drawing a tangent line to this curve at this point right here, then we're going to take our ruler and we're going to adjust it until we're just barely touching that curve. And what you'll find is that the tangent line is unique. There's only one way to draw it. If you do it a little differently, you end up intersecting the curve again. So the tangent line's unique. There's only one way to draw it. Here's what I think confuses people with a tangent line. When we say tangent at a point, then if I want something that's tangent at this point right here, there it is, tangent. It's only touching it at one point. However, if I were to continue with this line, do you see I'm going to recut the curve again? So when we say something is tangent, it means it touches the curve at one point and only one point in this vicinity. Right? So yes, if the curve cuts back and forth, then you're going to cut it more than once. But it's still tangent at this point. So it's tangent here. Okay, obviously it's not tangent here, but right here it is. Okay, when we say a line is secant, then when we have a secant line, then it cuts through the curve twice. So a line that touches the curve in 2 or more points. Okay, so we're going to, in calculus, spend a lot of time trying to find the slope of the tangent line to the curve at a point. Usually we'll have a point that's been given to us. So as you recall, when you're finding the slope of a line, you're looking for the change in y divided by the change in x, rise over run. This change in y is y2 minus y1 over x2 minus x1. We're going to take this equation, m is equal to y2 minus y1 over x2 minus x1, and we're going to rearrange it. That is, multiply both sides by x2 minus x1, and we get m times x2 minus x1 is equal to y2 minus y1. And then we're going to solve this for y2. Add y1 to both sides. I get m times x2 minus x1 is equal to, add the y1 to both sides is equal to y2. So this is another way for writing the equation of a line. So if you have a point on the line, so if I have this point, x1, y1, and I know what it is, then I substitute that point in right here. And all I'm left with is the slope, and if I can find that slope, I get this for my equation of a line. Y is equal to m times x minus x1 plus y1. I know you're most familiar with writing the equation of a line as y equals mx plus b. This is an alternate way of writing it. It will make things quicker in calculus if you get comfortable with this format. Okay, so here is our job in a nutshell. When we want to find the equation of a tangent line for some point that we're given on a curve, the first thing we need to know is the slope. But we have a problem. And the problem is that when you're trying to find a slope, you need 2 points on the line. And I'm only given 1 point on the tangent line. So let's just summarize our problem. So we have a problem. We only have 1 point. I'm going to call this point here P. But we need 2 points. To find a slope. Okay, so here's our solution. We are just going to approximate the slope. We approximate the slope by choosing a nearby point. I'm going to call that point Q. And finding the slope of the secant line, and I'm going to call that the slope of the line that goes through both point P and Q. This is called the secant line. Okay, I'll draw you a picture in a minute to help clarify this. Okay, so then this is what we say. We say that the slope of the tangent line is the limit of the slopes of the secant lines. Here's a picture. Could you guys draw this? Okay, so let me just zoom this in and we'll talk this one through. Okay, so here's my curve, y equals f at x. Oh, I'll do it on here instead of the screen. Y equals f at x. And here's my goal. I want to find the slope of the tangent line to this curve at this point. I'm going to stop recording.